Yes, so good morning students. Now, so last class we are actually doing the experiment, right? Photoelectric effect experiment we are observing, right? I will just explain that also little bit briefly, okay? So that you can get, now last class I was trying to explain it little bit variation. Now you see, I just explained last class there is a quads cover, right? Okay. Now here it is collector plate, correct, right? Here it is, sorry, here it is emitter plate and here it is collector plate. Correct, right? Now here it is the light rays falls, okay, light rays just falls on the surface. I will, no, light rays falls on the surface and electrons will come out from the emitter plate, cathode, correct, right? Okay, and they will just attract towards the collector plate, anode, and both are connected with a compiler. They are connected with a compiler, where again it is connected to a battery. Last class I was little bit, no, I tried to explain it. Yeah, there resistor will be there, voltmeter will be there. Yeah, the voltmeter with a one micro ammeter, correct, right? Okay. This is fine. Yeah. Okay. This is a battery. This is positive potential and negative potential. Okay. So whenever a light rays falls on the collector cathode plate, okay, the electrons will come out from the cathode plate and they will enter to the anode plate, which is collector plate. What plate it is? Collector plate. Okay. This is cathode and this is anode. Okay. Now, so you see, a suitable frequency of light rays enters through this quartz material. Okay. Okay. And this quartz window. What will this window will do? It will suitably select the light rays, proper light rays, and it will pass us through this that quad window. This is a window, and it falls on the metal surface. So electrons will come out, and this anode will collect it. Anode will collect it. Okay. Now you what happens? This battery is there, no? This battery is a, it will give potential difference. Okay, or voltage it will give. It will give positive voltage to the anode and negative voltage to the cathode. Artha ida? Understood? What it will do? It will give the, sorry. Yeah. It will give, that battery will give the positive potential to the anode. Why positive potential will give? I explained last class. If it will give to positive potential, electrons will attract towards the, yes, this positive. And if I give negative potential, electrons will be repelled. Electrons will come out easily from the metal surface. This is the function of the battery. And whatever the electrons it will attracted by this cathode collector plate, that it will show in the microammeter. That current, it will, deflection it will show. Understood? Understood? So how much voltage difference we are maintaining is given by this voltmeter. Understood? Okay. So this is what the experimental observation, experiment what they will do. Now what they finally observed is, okay, immediately when the light rays falls on the metal surface, okay, the electrons are coming. When the light rays falls on the metal surface, what happens? Electrons are started coming, and that too, it depends on the nature of the material. So instantaneously, what are the observations from this experiment is, observations, the electrons are, okay, electrons are ejecting or coming out from the metal plate instantaneously. Instantaneously. Instantaneously is how much? 10 to the power minus 8. Sorry. Wait. What happened here? It will go up immediately back. Yeah. Fraction of seconds. What is that fraction of seconds? You know how much? Fraction of seconds. You don't know. It is within 10 to the power of minus 8 or 9 seconds. Minus will not come. 10 to the power of 8 seconds. 10 to the power of 8 seconds, right? So it's not correct. Very less. In the sense, see, 10 to the power of 8 seconds only you take. Within a second, second means it's a huge amount. Okay, very fraction of seconds, the light rays will just fall. Immediately these electrons will come. It will immediately, this ammeter will show the current deflection. Okay, so that's why it is called instantaneous. Instantaneous. Understood? Next thing what they observed is, whenever there is a variation of potential, here I gave for a cathode I gave negative potential. If I go on increases the negative potential, the number of photoelectrons coming out is increases. Understood? The number of photoelectrons coming out is increases. Maximum potential difference if you give, maximum potential difference if we give, then what happens? The number of photoelectrons coming out is also increases. Number of photoelectrons coming out also increases. Photoelectrons coming out also increases. Coming out from cathode plate. Cathode. What is cathode plate means? Emitter plate. Okay, emitter. Metal plate increases. This is what they observed. So it depends on the potential. Okay, how much potential you are giving for the metal surface, what is the potential you are giving, and how many electrons are coming out. Okay, so this is what some of the observations. So this compiler, this is a compiler, not compiler, sorry, commutator. Last time I written compiler. It is commutator. What this commutator will do, you know, for example, if you want to change the potential, okay, here cathode I gave negative potential. If I want to stop this negative potential, if I want to bring potential difference 0, if I want to reduce the potential difference, what will happen? The commutator will change. You can change, okay, because there is a connections. This commutator can change negative potential. It will make positive here. It can make negative here, so that it will differentiate. It will reverse the potential. That's what the function of commutator. This micrometer will observe the deflection. This voltage will show how much potential difference you are giving between the two plates. Understood? Okay. So this is the experimental observations of, this is what little bit observations, but the maximum observations we will study now. So what is the first thing is, how that variation of, photoelectric effect with respect to the light intensity, frequency and all we will study now. Understood? First one, please write this application, or it is an observation. Okay, right? Observations. observations of experiment, photoelectric experiment. Now you see, we will study each and everything. Number one, variation of, please write, variation of photocurrent with respect to brightness or intensity of light, incident light, intensity of incident light, variation of photocurrent with respect to the intensity of the incident light. Now you see, last I was telling, you see, whenever the incident light falls on the, incident light means you should write arrow, okay, this incident light falls on the metal surface, okay, the intensity of the incident light is more. What is intensity means? Brightness, understood? Maximum brightness, maximum intensity of light falls on the metal surface. Now what happens? Photocurrent starts increases. Number of electrons coming out from the metal surfaces are increasing. Okay, on the metal they taken one metal. Now when the light rays just falls on the metal surface, if the light rays is dim, number of electrons are coming are less. If the light rays is highly focused, highly intense, more. For example, this lights you see, the light intensity is more. Now what happens? Number of electrons are coming out are more. So that is what the first observation from this experiment. Okay, this is observed, experimentally they observed. Whenever the intensity of light increases, intensity means brightness, understood? Intensity means brightness. Intensity is directly proportional to square of the amplitude of light. Amplitude means, you know, right, the maximum displacement of the light wave. Okay, when you study in your first year, right, a light wave, it's going like this, for example. From the origin, what is the maximum displacement of the trough? This is what we call amplitude. If the amplitude is more, okay, then intensity is increases. Square of the amplitude is intensity. So if the intensity or brightness is more, what will happen? The number of electrons are coming out from the metal surface is increases. And here this quartz window is there, no? This window will supply the proper like proper light rays. For example, if the metal plate gives maximum electrons to UV light, then it will provide UV light. So we need to set that UV light will give maximum electrons when the intensity of the light rays increases. So whenever the electrons are more, what will happen to the photocurrent? What is current means? Flow of electrons, correct, right? Flow of electrons is current. If the number of electrons increases, what happens? The current will increases. So photocurrent increases. How it will increases? That's what here it will show. Variation of photocurrent with respect to the intensity of incident light. Whenever the intensity is maximum, so intensity is directly proportional to, okay, photocurrent I. Okay, current, you can write photocurrent. Photocurrent. Understood? Okay, intensity is directly proportional to photocurrent because intensity is directly proportional to number of electrons coming out, number of electrons emitting from the metal surface, emitting from metal surface. if the number of electrons emitting from the metal surface is more, then what happens? The photocurrent increases. That photocurrent increases means what? That ammeter will show maximum deflection. Understood? If the light rays are more strong, more intensity, brightness of the light ray is more. Now what happens? Maximum electrons will come from the cathode to anode. That anode if we given positive potential, so that it is a collector plate. It will collect the light rays. Understood? It will collect the light rays. This anode will collect the light electrons, not light rays, electrons. The light rays falls on the cathode plate, and it will give out the electrons. That electrons is collected by the collector plate, which is anode. Understood? So means current increases. The current flow of current is increases. When the flow of current increases, what happens? It will show maximum deflection. That means maximum photocurrent is coming. Now how that relation is true here? You see, the graph shows graph of photocurrent which is I with respect to intensity of the incident light ray. Intensity. Okay. So as the intensity increases, photocurrent increases. It is linear straight line. Okay. If intensity is less, photocurrent is less. As the intensity increases, what happens? Photocurrent starts increases. It's a straight line. Understood? Okay. So this is the first observation they did. So the number of photoelectrons or photocurrent is directly proportional to the intensity of the incident light. Please take this. Done now? Okay. The second one. Second observation. Variation of photoelectric current or photoelectric effect. Photoelectric current only I will take. Photoelectric current with respect to potential. See, potential. Where potential? You see here. If the I will take the graph. Okay, here it is photoelectric current. And here it is, I will write potential, voltage or potential. Okay, so here it is positive potential and here it is negative potential, negative V. Here it is positive V. Positive V. V is potential. Understood? Where we will give potential? You see in the diagram, we written there is a cathode and anode plate. We are giving from battery potential difference. Correct, right? From battery, first I gave negative potential to cathode plate and positive potential to anode plate. Why I gave negative potential to cathode plate and a positive potential to anode plate? This positive potential will attract the electrons. Since it is negative potential is given to the emitter plate, electrons will be repelled. They feel the force of repulsion. Now what I will do, using the commutator, everyone's here, using the commutator, I will reverse. I will slowly decrease the negative potential given to the emitter plate. Slowly I will decrease. That means I am also decreasing the positive potential to the anode plate, collector plate. Slowly negative potential I will decrease, and here also positive potential I will decrease. That means from battery I will decreasing the potential. Listen here. From battery I am decreasing the potential. Now what will happen? Flow of charges also, no, it will decrease. Whenever potential I am giving to the plates decreases, the flow of charges also decreases. The flow of charges also decreases. Now what happens slowly? I will make, using commutator, the potential difference 0. Potential difference 0. Now will the charges, flow of charges decrease as 0? Since light rays are falling, so most energetic light rays are falling, it may not be 0. Since small electrons may be going, since charges will flow but not maximum. If you make the potential 0 also, the flow of charges will not be 0. It will not be 0. Still there is a flow of charges. Still you will get the photocurrent, but it will be reduced. Understood? Photocurrent will be reduced. Now, as I started on increasing the reverse potential, I will start applying positive potential here and negative potential there. Now what happens? Okay, positive potential will apply to the cathode and negative potential will apply to the anode. Negative potential, if you apply, what happens? The electrons which are coming towards the collector plate, repel. Correct, right? No, positive potential applied to the emitter plate. Now what happens? Electrons will reduce in going out. Even negative potential applied to the collector plate. Negative means this negative and charge is also negative, electron is also negative. Negative or negative, what happens? Repulsion develops. So the moment of charges, flow of charges will decreases. The flow of charges will decreases. Whatever the intensity of light ray. If the intensity of light ray is more, number of charges flowing is more. But since we are giving the negative potential to the collector plate, what will happen? The flow of charges will be reduced. It will feel repelled. They will not come near the plate. They will start repulsion and they will fall there on. Understood? Okay, that is the second step. Yeah. Whenever, okay, so you see here, this is positive potential. Okay, this x-axis, positive potential is here. This is positive potential, and here it is negative potential. Here it is negative potential. Since positive potential on the positive x-axis, negative potential is on the negative x-axis. Understood? Now what happens? Now you see, positive potential is given to which plate? First. No. Positive potential is given to collector plate. When the positive potential is given to collector plate, what happens? Maximum number of photocurrentons it will is attracting. So slowly what will happen? I will make it 0. You see, for example, I will take some intensity of light, I1. Okay, when the positive potential is maximum, the photocurrent is maximum. Slowly I will decrease the positive potential. What will happen? The photocurrent also start decreases. Slowly I will decrease, I will decrease, I will decrease, I will decrease. I will make the potential 0. Since the current flow will be there, photoelectric current is there. Because number of flow of charges will be there. It will be there. Understood? So whenever positive potential, see, positive potential is maximum, photocurrent is saturated. It is there. But whenever it is started decreases, what happens? Photocurrents also start decreases. See. Understood? So at even when the current for positive potential is 0, photocurrent is still exists. But once it is negative, okay, once it is negative, what happens? You see, the current stops 0 at one point. The photocurrent stops. Negative potential where you are giving? You are taking this potential is at a collector plate only. You take collector plate. Don't confuse. Don't make confusion. Which plate it is? one is emitter plate, another one is collector plate. Understood? Now from the battery I will give positive potential to emitter plate, negative potential to before that using compiler first what I will do, I will give negative potential to emitter plate and negative potential to emitter plate and positive potential to collector plate. Okay, slowly what I will do, I will do reverse by using not compiler, what is that? Not compiler, commutator. Okay, I'm really compile. It is compiler means it's compiling, mixing. Okay, it's not a wrong word. Commutator. Whenever you commutator, if you use, I will reverse it. This negative potential I will make it positive. You leave this emitter plate. You take only collector plate. Before what we are giving to the collector plate, positive potential. Slowly what from positive potential, slowly I will do, I will give negative potential. Okay. If I give negative potential, what happens? The current flow will be stopped. This one will be there, no? The micrometer will show zero deflection. Understood? Current flow will be stopped. That is what? That potential is what we call stopping potential. What we call? Stopping potential. You can write here, it is V0, negative V0, minus V0, minus V0, because it is negative potential. Okay, now I will take higher intensity wave. Let's listen here. I3. One more you take, I2. Listen here. Intensity I will increase more. Intensity of light falling increase more. But if you go on applying negative potential to the collector plate, what will happen? Maybe at one particular point it will be there, but stopping potential is same. For this also stopping potential is same. As intensity increases, what is photocurrent also increases. I3 is intensity of the third light ray is greater than I2, which is greater than I1. Okay, photocurrent also increases. Photocurrent also maximum. Even if the potential is zero, photocurrent is not still zero. Still it will be there. But as the potential is negative, negative potential applied to the which plate? Which plate? Collector plate. From positive we are making it to negative. Now electrons will feel repulsion near the collector plate. I have written collector plate potential. That time the electrons will be, the current flow will be zero. But the potential is same for the given material. Whether intensity is high or low, the current is same for the given material. That's why it is called stopping potential. Negative V0 is also called stopping potential. Stopping potential. Okay. Now please write, a stopping potential is a stopping potential is a negative potential given to the collector plate, collector plate is also called anode plate. Collector plate, so that the photoelectric current, what happens? Stops, that is photoelectric current is zero. The flow of charges stops. Actually the photoelectric current is zero and flow of charges stops, you should write. Okay, so that the photoelectrons, so that the photoelectrons stops, the photoelectrons coming towards coming towards coming towards the collector plates, what happens? Stops. Coming towards the collector plate, stops. In the sense, photo current is zero. This is what we call stopping potential. Okay. So stopping potential is independent of, write this point, stopping potential is independent of what? Tell. Stopping potential is independent of intensity of incident light. Independent of what? Intensity. Intensity of incident light. Incident light. Is it depends on intensity of incident light? Whatever the intensity you take, you see stopping potential is same. Intensity ಯಾವುದೇ ತಗೊಳ್ಳಿ, ಜಾಸ್ತಿ ಇದ್ರು ಕಡಿಮೆ ಇದ್ರು, whatever it may be, stopping potential is same. Understood? So that's why it is intensity of independent of intensity, but it depends on what? Depends on what? Huh? Stopping potential depends on what? See, it is stopping potential is same for what? Material. You take one particular material, okay, stopping potential is same for that. It depends on the nature of the material. Understood? Stopping potential is depends on the nature of the material. For a particular material, the stopping potential is same. Okay, but it is independent of the intensity. Please write that also. That point you write. Here also you write. Shall I take in the next line? You want to write? Yes. Understand properly. What is the, where stopping potential, how it depends? Tell. Stopping potential depends on intensity. Mind is not there here. Where you are? Stopping potential depends on intensity. Intensity you take I1, I2, I3, any intensity you take. Stopping potential is what? Constant. It is not depends on intensity. So where it depends? It depends on nature of the material. For a given material, stopping potential is constant. Take that. You write here and I will write here, okay? Stopping potential depends on the nature of the material. Nature of the material. For a given material, stopping potential is same. Okay. Next. I will add new. Done now? Now, please tell if the intensities are different. stopping potential is different. Okay, so this was clearly you will understand when you understand Einstein's photoelectric experiment. Einstein gives very nicely, that we will discuss today. Okay, I will explain it. Then you will understand, oh, this is where this is where. Now the third one you write. Third one is, yeah, the variation of the variation of potential, stopping potential or potential with respect to frequency. With respect to frequency of light. Okay, there we are discussing now photoelectric effect is instantaneous. What is its time duration is 10 to the power of 8th second. No, not 10 to the power of 8th second. It is like in, okay, within, okay, for example, you take within 1 second, 1 by 1000 times, or 10 to the power of 8 means 1 by 10 to the power of 8. Very fraction. Suddenly, that current will flow. Okay, that's why I mentioned is within the fraction of 10 to the power of 8 second, the electrons will come. Okay, that are given that is 10 to the power of 8 or 10 to the power of 9. Okay, in that range. Now what is the variation of potential with respect to frequency of the incident light ray? Okay, now you see what is frequency. First you need to understand, whenever light rays will come, okay, they will fall on the metal plate. Okay, so electrons will come out, correct, right? This is the metal plate, which is emitter metal plate. Okay, electrons will come out, correct? Now if the energy of the light rays is E is equals to h mu, E is equals to h mu, energy. Mu is what? Frequency. Mu is what we call frequency of the incident light ray. So energy depends on, that means the strength of the light ray depends on frequency. Okay, so you can also write the velocity of light ray is what we call lambda into frequency. Velocity of light ray is also what we call lambda into frequency. So energy is depends on this frequency. I am writing in terms of mu. You can also write in F or mu, lambda mu. This is mu. Energy you can write it as h mu. What is h? Planck's constant, 6.625 into 10 to the power of minus 34 joule per second. That is the value of the h. Understanding? Okay. 6.625 into 10 to the power of minus 34. 10 to the power of minus 34. Very difficult to write here. Correct, no? Into 10 to the power of minus 34 joule per second. And F frequency. So that is the energy of a light ray. Understood? When that energy of the light ray falls, no. So as frequency changes, energy changes. Energy changes. Now the electrons will come so rapidly. The electrons will come so rapidly. What they are observing in the experiment, I am telling. Reason I will tell later. What they observed is, as the frequency increases, different frequency, the electrons they collecting, no, okay, they need to apply different potentials, stopping potentials to stop the electrons. Okay, so what they got is, you see, collector plate. This is a collector plate, no? They are applying the potential through a battery. Okay, using compiler. From battery, they will apply negative potential here. Correct, right? Negative potential means there is a repulsion will come. Okay, so you see photoelectric current, I, and here it is potential, same diagram amma, potential, which is V. Here it is positive potential and here it is negative potential. Okay, understanding? Now for different frequencies, frequency F, so I was writing F, actually I will write mu. Okay, so mu1, take intensity, same intensity, intensity of light is same, frequencies are different now. Okay, frequencies are different. Now you see stopping potential is something. Okay, okay, this is I will write it here as minus V01. Now if the frequency is different frequency, okay, then it is minus V02. Stopping potential starts increases when the frequency and intensity changes. Frequency and intensity changes. See, frequency mu1, mu1 is less than mu2. Frequency mu2 is greater means stopping potential is also greater. Frequency mu1 is less, so stopping potential is less. Okay, for example, if intensity is same, now you see, don't get confusion, I will explain properly once again, listen. Okay, okay, photoelectric current, which is I. Okay, now intensity is same, I only, every current light ray is intensity is same, but if the frequencies are different, now you see what happens. You see, intensity is same, photocurrent is same. Listen here, intensity is same, photocurrent is same, but you see frequencies are different. This frequency is mu1, this frequency is mu2, this frequency is mu3. That means energy of the light rays are different. Now you see stopping potential, it is minus V01, minus V02 and minus V03. You see, different stopping potentials are coming. Okay, different stopping potentials are getting. So if you take for frequency mu1 is less than mu2, is less than mu3. Okay, now energy of E1 is less than E2, which is less than E3, because energy depends on frequency. Definitely stopping potential of E1 is less than E2, which is less than. That means maximum negative potential you need to apply for the highest frequency. Maximum frequency is there. For example, incident light ray is having maximum frequency. That means maximum energy. Now stopping potential is also maximum. So you need to write here, the conclusion is that stopping potential is directly proportional to, please write down, stopping potential is directly proportional to frequency of the incident light. Directly proportional to write down frequency of the incident light ray. Incident light ray. Correct, no? So frequency ಜಾಸ್ತಿ ಇದ್ರೆ ಏನಾಗುತ್ತೆ? What happens? Stopping potential also increases. Okay. Maximum frequency, maximum stopping potential. Where stopping potential means what? Where with the potential is applying? Negative potential applying to collector plate. Collector plate, we are applying negative potential so to stop the flowing electrons towards it. If the frequency of the incident light ray increases, the electrons will come out with maximum force, maximum kinetic energy. So they will come very fast. So to stop that electrons, you need to apply maximum negative potential so that the electrons, even if they come very fast now, they will stop. They will not attack. They will not, current will not increase. Understanding? Understanding or not? Okay. For example, the light of maximum frequency, so much energy will be there. It will fall. Electron will come out. Electron just not only it will come out, it will come with maximum kinetic energy. Fastly it will come. So if you want to stop it, slow it, you need to apply negative potential more in the collector plate. Now negative potential means electron, negative potential, both are repels. The electron is also negative charge. Potential is negative. What will happen? It will repel, so that it will stop. It should not come out, go out again back actually, but it will stop and electron will stop. So current will be 0. Understanding? Understanding? Please take this. Finished? Yes. Any doubt? So stopping potential is directly proportional to frequency of the incident light ray. Understood? So please write the observations now. So what are the experimental observations? One by one you please mention. Experimental observations. Please mention one by one. Number 1. The photoelectric current is directly proportional to what? Is directly proportional to intensity of the intensity. Correct? No, that is what first one, right? Intensity means brightness. Incident light ray. Intensity of incident light ray. Second one. What's the second one? The stopping potential is independent of intensity of light. Correct? No? The stopping potential is independent of intensity of incident light ray. Intensity of incident light ray. What is the third point? Stopping potential is one more point I mentioned. The stopping potential depends on the nature of the material. Write that. The stopping potential depends on the nature of the material. Nature of the material. Material, MEA, I will write MEA. Okay. Next, one more observation. Stopping potential is also depends on frequency of the incident light. Write down. Stopping potential depends on, ಅಥವಾ stopping potential is directly proportional to what? Frequency. Frequency of the incident light. Frequency of the incident light. Understood? Huh? Okay. Next, what else? That's all, right? One more is, it is instantaneous. Photoelectric effect is instantaneous. Instantaneous process. Okay, so these are few observations. There are so many observations actually. Okay, so please take the heading Einstein's photoelectric equation. Einstein's photoelectric explanation. So this experiments, it is showing some results, right? Now why these different the differences, why there are different properties, experimental observations? Who gave correct explanation? Means Einstein gave the correct explanation of the photoelectric effects that we will discuss now. Okay, so please take this. I will discuss Einstein's photoelectric. Shall I erase it? Please take Einstein's photoelectric. You write Einstein's experiment or Einstein's photoelectric equation. You write photoelectric equation. Then we will write Einstein's observations. He also analyzed the experiment. Okay, then he gave beautiful explanation. For that he got a Nobel Prize. Okay, understood? So now please start what Einstein assumed. See, now we understand what happened. Light rays will come, they will fall on the surface of the metal. Okay, so when they fall on the metal surface, what happens? Electrons are coming out. That electrons are collected by the another metal plate. So why light rays, when they fall, electrons are emitting? This is what Einstein thinking. What he gave equation, expression, and it was direct conclusion. That expression immediately it is giving the results. Oh, this photoelectric happening in the same way. What he observed, you see, very interesting. So according to Einstein, he taken this, for example, a metal plate, the surface of the metal plate. For example, here one electron is there. Why electrons will come out, you see? You'll observe. You people played this marble game, huh? Goli. Marble. Goli. Correct, no? There is one small hole you will make in that surface, no? Then you will put no marble to remove that electron. In the same way Einstein thinks. Okay, for example, there is one hole in there. That means the electron is embedded inside the hole. This hole, it is not like hole where it is, there are so many electrons will be there, but this is one electron which is in valence bond. Valence electron will be there, free electron will be there. What Einstein says, whenever a suitable light of energy, light ray of energy E is equals to h mu. E is equals to h mu. Energy is equals to h Planck's constant into frequency. Energy of suitable energy E is equals to h mu falls on the metal surface. Falls on the metal surface. That light, Einstein considered light as a particle. Light as a particle nature. Okay, that particle, light particle, okay, because light is a quantum. Einstein says light is made up of quantum of particles. They are made up of quantum of particles. Quanta he calls. That particles is called quanta. Quanta means what? And they are discrete in nature. Remember this. Quanta, discrete. What is discrete means? I explained last class. What is discrete? In discrete, they are not continuous. They are discrete. Discrete means what? Discontinuous. Okay. See like this. See, this is continuous, no? Discrete means what? Discrete. For example, if you open the tap of water, if you open very slowly, what will happen? Drop will come. No, like particles, light particles like that only. He said, they are like the discrete. They are discontinuous, discrete particles called photons. He mentioned them as photons. And they have the packets of energy. Light is energy only. The particles is energy particles, and that energy particles are like in packets. That packets only quanta we will call. The quantum of packets of particles. They are the particles of the light have a discrete energy called quanta. Quanta. That quanta packets. Okay, and they have the energy E is equals to h mu. Using Planck's, Max Planck was the scientist who introduced that H. He gave the theory of, energy will be in the form of quanta, and Einstein used it. So this light particles will hit the electron. Electron is also a particle. Whenever one marble hit the another marble, what will happen? What will happen? This marble will fall and that marble will come out, or both will come out. What happens? Another will. Okay, you see, whenever this light as a particle come and hit the electron, this electron will take the momentum or energy from the light. I said light photons is having a energy. Mass and energy are interconvertible. That's what Einstein said. E is equals to mc square. Mass is nothing but energy. Mass is nothing but energy. That mass, it will give momentum, and this electron will take that energy. It will come out and it will move. It will come out and it will move. And you see, this region is there, no? This is what we call work function. You cannot W or pi anything. What is work function? Okay, you can write W or phi. Work function is the minimum energy required to remove the electron from the metal surface. The minimum energy required, to remove the electron from the metal surface. See what you are saying. So energy will come, and the electron will absorb that energy, that momentum it will absorb. Now what will happen? Some part of the energy will be used to come out from the work function. This work function is what we call h mu naught. H mu naught. It is the minimum energy to come out from the metal surface. Then what happens to the remaining energy? What will happen to the remaining energy? it will use that remaining energy to move away with some kinetic energy. Okay, so this electron will just come out and it will not stay, it will also move with some velocity. Understand? Okay, so Einstein said, if you throw some marble, or if you see, for example, you are playing a football game. Okay, while you are playing football game, you should kick the football so that it will move. Correct, na? Correct, na? So even if you are playing a marble, if you throw some marble, the next marble will come out. Correct, right? The marble which is inside, the goalie which is inside this cave, this one hole, if it should come out, means you should apply a maximum energy. If you slowly put the marble, this marble which is there inside the hole will come out? No. If you put very fastly you throw, it will not only come out, it will move again. That's what Einstein thinking. He said photoelectric effect is a particle nature of light. The phenomena of photoelectric effect, whatever it happens, is due to the particle nature of light. They are the quantum particles. So light falls, electrons come out. Electron will come out. If the energy is less than work function, what will happen? It will not come. That particle, that energy it will take, electron will take, but it will stay there only. It don't have energy to come out. If the light energy is equal to the work function, what will happen? It will just come out. Will it move? No. See, everything here only, solution. So that's why, you understood this Einstein explanation? Okay? So that's why here it is given, Einstein given, E is equals to h mu is what? Incident energy. Incident energy. Then E is equals to h mu naught is what? Work function. Work function. Then the third one, E is equals to half mv square is what? Kinetic energy. What it is? Kinetic energy. What Einstein says, you see, h mu is equals to h mu naught, h mu is equals to h mu naught plus half mv square. This is the greatest Einstein's photoelectric equation. H mu is equals to what? Incident energy. H mu naught is equals to what? Work function. Half mv square is equals to what? Kinetic energy. If the incident energy is equal to this, then electron will come and connect to the collector plate. It will come and connect to the collector plate. So here you can write cases. Case 1. Case 1. What is the case 1? If h mu is less than h mu naught. If the incident energy is less than work function, what will happen? Yes, photoelectric effect never takes place. If this is less than this one, this will be 0. This electron will not come out. Correct, right? Illi energy kodta iro energy idukkanna kadime idre electron mele barutta. It will not come out. Photoelectric effect will never takes place. So that's why if the incident light energy is less than work function, then photoelectric effect never takes place. Photoelectric effect doesn't take place. Correct? No? Does not take place. This is case 1. Work Coulomb, right man. So if it is h mu is less than h mu naught, then photoelectric effect never takes place. It's very fast, right? Then now, yeah. Next, case 2. So what is Einstein's equation? H mu is equals to h mu naught plus half mv square, right? Now case 2 will be, if h mu is equal to h mu naught, if incident energy is equal to work function, what will happen? What happens? If the incident energy is equal to work function, what will happen? It will just come out on, stay on the surface. Electron will not move. Electron will never move to the collector plate. Correct, right? It will just come out. Okay. So if h mu is equals to h mu naught, if this is equals to this, h mu naught you can also take as work function. If h mu is equals to h mu naught or work function, you can write W. Now what will happen? H mu is equal to h mu naught means half mv square is equals to what? 0. That means electron never undergo kinetic energy, never move with some velocity, or it will never move. Okay, it will never move, or you can also write it will never move. Sorry, but just come out from the what? Metal surface. Come out from the metal surface. It will just come out from the metal surface. It will not move faster. Just come out from the metal surface. That is case 2. Okay. Now, third case, case 3. Now what happens? If h mu is greater than h mu naught or work function, or also you can do work function W phi or W. Now what will happen to the equation? Move with some maximum velocity. Correct, right? So now if it is greater than, if h mu is greater than, h mu is equals to h mu naught plus half mv square. The time, that is that the electron travels. You can write, wait, don't write this. I will write proper definition. You see here, if incident energy is greater than work function, if incident energy is greater than work function, then the electron not only just come out from the metal surface, come out from the metal surface, but also move with maximum velocity, maximum kinetic energy, right? Maximum kinetic energy. Move with maximum kinetic energy. Understood? Ah? That's why this half hemisphere exists. Okay, shall I go to next? Done now? Okay. So what you finally understood? You see? If the energy is greater than work function, what will happen? It will move with maximum velocity. It will part of the energy it will use to come out from the metal surface, and remaining part it will use to move with maximum kinetic energy. That's what Einstein explanation. Okay, some more is there. I will discuss in the next class. Sure? Okay, thank you.